Okay, so now that we've obtained some evidence that morphemes matter for our behavioral measurements of priming, I want to turn to the question of how exactly our brains extract the morphemes from words. And let's start with the visual modality. So we're going to talk about reading first. And I want to contrast two different types of hypotheses or models. One hypothesis says that this morpheme extraction happens relatively late in processing, and the other hypothesis says that it happens early. So let's walk through the steps of the late decomposition hypothesis first. So this kind of theory would say that the first thing that happens is that you perceive the whole word form. So your visual system takes the whole word form in. You then try to search for a meaning for that whole word form. So let's just say it's, seeing. You look for a meaning for that whole word. Then if you don't find that meaning, if that element is not actually stored in your lexicon, as it wouldn't be if it's a complex form, remember we're now we've now ruled out the full form storage theory. We're just exploring varieties of the decomposition theory. So if you don't find the meaning, then you would decompose the word form into morphemes. So now it's like, okay, let's actually try to extract some pieces from this and see if those will have meanings in my mental lexicon. So then you go ahead and search for meanings for the morpheme forms. You would successfully find them. You would find the pieces, and then you would combine them together. So remember our cartoon lexicon. So imagine if it has like magnet and ick, you would like, okay, great, I'm now going to be able to compose these together into a word and a complex meaning. So now for a morphologically complex form, that of course seemed like a lot of processing steps. But for a simple form like table, it would work really easily because you're already done at step 2. So you would just like see the form, look for a meaning, done. But for a morphologically complex form, it takes a little bit more work because you would first look for a meaning for the whole form, then you wouldn't find it, then you'd go back and look for the morpheme meanings. Okay, so that would be a late decomposition theory. What would the early decomposition theory then say in contrast? Well, here the fundamental idea is that the first thing that your system does is look for morpheme forms. So that means that in some sense, your perceptual system is tuned to finding these forms that have an independent life. Independent from the specific context where they're occurring in. So what I mean by that is like when you have like magnetic, you will see the ick and you know like, oh, this is a meaningful element in lots of different words, and in some sense your perceptual system therefore represents it as its own unit and is able to somehow spot it. That's the idea. So we're immediately finding those morphemes. Then we could go ahead and find the meanings of those morphemes. Access them, and then combine the morpheme meanings into more complex semantic representations. So that's a really good way to operate if you're a morphologically complex form like teacher. So you would be able to create the representation for this complex form pretty quickly. It's a really bad processing route though for words that are when we say sort of pseudo-morphologically complex. Turns out there's a lot of words like that in the languages of the world, including English. So look at these words. So corner or brother. They also have this ER suffix, which the perceptual, the ER sequence, which the perceptual system, because it doesn't know anything yet, it doesn't know anything about the meanings of these forms, it would see like, oh, ER, and then it would look at the rest of the form, corn. Well, that's also something that has kind of an independent life on its own. And so it would think that this form is actually morphologically complex. But now, of course, the most salient reading for corner is not somebody who corns, although maybe you could get that interpretation, but that's not typically how we interpret corner. And a brother is not somebody who broths. Okay, so these in fact are semantically, morphologically simple. So there is only one morpheme, but it just so happens, it's kind of just an accident of the form, that they also include this ER suffix. So this theory, although it's good for these really, you know, the forms that actually are morphologically complex, but it's bad for these kind of forms that are complex in a kind of fake way. And there actually are a lot of words like that. Nevertheless, even though it seems to be an inefficient route for the corner and brother type of words, this does seem to be the theory that seems correct. So at this point, we have quite a lot of evidence that actually what our brains do is something like this type of early decomposition. So I'm now going to show you kind of the core evidence for that. And actually, our neural investigation of this type of process has been critically informed by prior behavioral research. And so I'm going to show you that before we take a peek at the brain. And so this is a experimental paradigm that we haven't talked about yet. It's called masked priming, okay? Come up a little bit, but not properly. So I will now explain through this. So this is a very rapid priming paradigm. And what I mean by that is that the prime is presented so quickly that you're actually not consciously aware of even having seen it. Okay, so it gives you kind of like, it's a subliminal manipulation where something is just presented really quickly and subconsciously. So here would be our typical, priming setup. We have a prime, let's just say teacher, and a target teach. These are morphologically related, teacher teach. And in a mass priming paradigm, you would then oftentimes precede and sometimes even follow the prime with some kind of a character string that kind of masks it or makes it even harder to perceive. And so here, a typical priming paradigm would be one where you first get a mask, and then the prime flickers really, really quickly, and then you see the target, you're able to appreciate the target perfectly fine. It's presented for until usually you press a button. So now I'm going to try to just demo it here. I haven't set up any script for it, but I'm just going to do it within my PowerPoint. So the idea here is that in a priming paradigm, you would get these stimuli one after the other. So I'll first show you kind of slowly. So first there's the mask, then you would get the prime, then you would get the target. But if it's a masked paradigm, then it would go really, really quickly so that the prime isn't even visible. So I mean, something like that. Now you obviously saw it, but imagine that it's super, super quick. So that's masked priming. So prime flickers super quickly. Usually roughly 40 milliseconds is the SOA. Remember now we learned that term. So the interval from the onset of the prime to the onset of the target. So 40 millisecond is fast enough that you don't perceive it. The longer it gets, the more chance there is that you actually are conscious of the prime. So now you might think that that kind of a rapid presentation would not matter for processing at all, but it actually does, and in a way that is relevant for our morphological theories. So your visual system does see the prime, and the form of the prime affects target processing. So we can see effects of the prime on your button press times to the target, even though you're not consciously aware of having seen the prime. So specifically, what I mean by that, is this. So this is another study from Kathy Russell and colleagues. So here, the stimulus categories were as follows. So here we would have our straightforwardly morphologically related case: cleaner, clean. So cleaner is the comparative form of clean. You're noticing that ER actually is an ambiguous suffix in English, so it can be, you can also use it to derive the agent of an action, like teacher, teach, but also a comparative adjective, cleaner. That's a topic for another day. So here's our morphologically related case, cleaner, clean. And then they had these pseudo-related cases like corner, corn. And then finally, so it's kind of a fake morphological relationship. These don't have anything to do with each other semantically. And then finally, they had cases like brothel, broth. So not brother, broth. That would be belong to the second condition. Brothel, broth. This is different from corner, corn in that L is not a possible English suffix. It's not an English suffix. And therefore, this pair is not morphologically related and not even pseudo-related, because you cannot decompose the, so you can't superficially decompose the form brothel into broth and L, because L is not a suffix. Okay, so that's the crucial difference between corner and brothel, brothel, broth. Okay, so the interesting result in this experiment and many follow-up studies is that in masked priming, in this really quick type of priming where the prime just flickers and then you respond to the target, cleaner, clean and corner, corn showed exactly the same amount of positive priming. So equivalent positive priming for both of these cases. So cleaner makes you faster at clean and corner makes you faster at corn, but brothel does not make you faster at broth. Okay, and that's really interesting because the amount of form overlap between corner, corn and brothel, broth is the same. However, the fact that corner has this kind of like pseudo morphological complexity, it looks like it could be morphological complex, but it just isn't. That seems to be what's critical. So these kinds of results show us that at very early stages of visual processing, the processing system seems to kind of spot the morphemes, so that at this kind of very fast presentation times, it's still at that stage where it's like, well, there was like the two morphemes, and so then it's in some sense going to make the mistake that that was morphologically complex. Okay, so these findings support the early decomposition theory. So it seems that our brains very quickly decompose complex forms into the subsequent constituent in a semantically blind way. So, and when I say semantically blind, what I mean is that your brain does not know that corner, the word corner, doesn't have the meaning corn in it. Okay, it's not a derivation from the noun corn. So that's the blindness. So later on, it presumably figures that out. And so now, having armed with this behavioral finding, we can ask the question exactly when and where this actually happens in the brain. And so now in the visual modality, we actually have a really good candidate region for the process, the visual word form area, because now in some sense this finding is telling us something about the nature of the forms that we search for in those early processing stages. So we would want to then find out whether the visual word form area actually is sensitive to morphological structure. So that is something that I and a student of mine, Eitan Zweig, actually tested many years ago now. And so this was the first kind of neural test of this hypothesis, and we used MEG to test it. And so now here, because now we're measuring activity from the brain, we actually wanted to have the simplest possible paradigm to assess this. And so for that reason, we just asked the subjects to perform lexical decisions on individual words. So there's no priming in this study. And so here, just super simple, the subjects are either reading bimorphemic words like teacher, so two morphemes, that's bimorphemic, teach-er, okay, so that decomposes into those two parts, versus something that's just a single morpheme, switch, versus, and this was our kind of orthographic control, winter. Okay, so here, this now has that ER suffix, but the rest of the form does not represent a possible morpheme. So there is no morpheme wint in English, okay? So this is not like corner, because the form does not exhaustively decompose. There's an ER, but the rest of it does not represent a morpheme. So this was a bit of a test case at this stage in the literature, but turns out that it patterned with the monomorphemic case, and that is the kind of finding that's consistent with subsequent research. And so what we learned is that yes, the M170 response, which remember we think originates basically from the visual word form area, was sensitive to the manipulation of morphological structure. So specifically, we saw larger M170 amplitudes for the bimorphemic words. So, you know, that can plausibly be interpreted as reflecting sort of seeing two forms as opposed to just seeing one form. And interestingly, in that early study, although we saw the effect in the left hemisphere, so here's the M170 amplitudes, and the blue lines are the morphologically complex cases, the effect was very much bilateral in our hands at the time. So it's possible that the right hemisphere fusiform cortex also responds to morphological structure. Subsequent research has actually not explored the right hemisphere effect systematically at all, so there are still a lot of open questions about that I actually think are interesting. But the generalization that has kind of carried on to current times is that the left hemisphere visual word form area does respond to morphological complexity and seems to be kind of the neural source of these early decomposition effects, and including for the kind of corner cases. So here, just to sum up the visual part, so now this is kind of like, just so you can really intuitively get the idea, I'm kind of running your morphological processing system in slow-mo to demonstrate how, you know, it could be that these morpheme forms are sort of spotted in our brain. So here's your brain in slow-mo, starting to see a form. So it's kind of fuzzy, but very quickly it spots the subsequent morphemes from it. And then when you get a form that is, at this point, it's just a fuzzy representation. You don't know anything about the meaning of this form, but you're seeing these two forms that have a certain kind of distribution in the language, so that, you know, they chunk together in many contexts. And so for that reason, you would see those two forms at these early processing stages. But then at some point, your language system tells you that teacher is in fact someone who teaches, but corner is not someone who corns. And so in a sense, well, not in a sense, the analysis of corner as someone who corns has to kind of be canceled out. Could also be the case that you have parallel activation of the whole form corner and the decomposed form. That's a plausible hypothesis. It turns out that morphological structure outside a priming paradigm, so when we're just pushing buttons in response to these kinds of forms, does not tend to really affect your behavioral responses. So you have to do something like priming in order to kind of reveal behavioral effects of morphological structure. So this is how things seem to work in the visual modality. And so next I want to talk a little bit about how these ideas translate to the auditory modality, where things are quite different. So that's next.